Hey everybody, this is Michael from Bright Musical Circuits, and this is the new Clippers module, and I'm going to do a little schematic walkthrough for this. So looking over here on the left, we have our 4 input jacks. We've got 4 sets of Clipper circuits, 2 using 1N4148 diodes and 2 using LEDs. And the top 2 are in the hard clipping formation, which means that our diodes are just back and forth going to ground. And our bottom 2 are using the soft clipping formation, where they are in the feedback path of an op-amp. So starting with this top one, we have a 100K input resistor, followed by a resistor to ground, which on this top one is a 1.2 M, and here it's just a 220K. This 1.2 M is actually so large that you don't really need it, but if people were going to modify these circuits, I wanted to leave that in there so they would have a point to swap in a different value. But what these do is they are attenuating the input signal a little bit. And they're doing that so that so you can control the amount of signal that's getting clipped. Basically what these diodes are going to do is they're going to limit the signal that passes them to just plus minus the forward voltage of the diodes themselves. So the 1N4148s, that's about 0.7, and the LEDs I think it's 1.5 or something like that. I don't remember. And also this is a module that I didn't really do any math when designing. I had the basic topology figured out, and then I was just substituting resistor values and checking it on an oscilloscope to get the waveforms looking how I wanted them to and how I thought they sounded good subjectively. But so yeah, we are attenuating our input with these 2 resistors, and then we are clipping it with these 2 diodes. So whenever the voltage exceeds the forward voltage of the diode, it gets just sent straight to ground and clipped off. And then after that, we've got makeup gain provided by these op-amps. And this is a non-inverting op-amp, so we have our input phase and output phase the same. And this is just providing some gain. So the diodes are making our signal very small, and this is returning it back up to large or normal size. And as you can see, it's different values for the makeup gain for the 2 of them. The 1N4148s are making the signal a lot smaller, so it needs a lot more makeup gain. And so then in our soft formation, it's a very similar thing. We're attenuating the signal again, but this time instead of having a resistor to ground, we have a resistor providing negative feedback to the input of this gain stage. So if we look at this gain stage and we just ignored the diodes, this would basically look like a inverting gain stage with a gain of negative like 0.2, because the 22K is 22 over 100 is 0.22. But then by putting these diodes in there, it's going to be something with a gain of 0.2, but also anytime it's exceeding 0.7 volts, it's going to then clip. And so this gets a kind of a different feeling of distortion. And so we're doing active attenuation instead of just attenuating the ground. And that feedback and the diodes affecting the feedback just affects the sound a little bit differently. And then the output of that is then fed to another op-amp stage. So our first op-amp stage was inverting, so our second makeup gain op-amp stage is also going to be inverting so that the phase stays the same from input to output. As standard on a lot of modules, I'm using 1K output resistors before the output jacks. And then the power supply setup is the same I normally use. This is an MOTM style connector. This module is set up for Eurorack style jacks to be mounted on the board, but you could also use it in another system. The power comes in. This is the positive and negative rail here. And then this 10 UF and 10 ohm resistor, these form a low pass filter for the power. And then these 0.01 UF caps get placed right by the power pins in order to do some extra filtering. But yeah, that's how this works. Thank you for watching.